Dom?
Yes.
Can you forward the link to the YouTube channel? It's broadcasting.
Up there. That's the link.
Okay, I'm going to send the link to Kim just in case anyone from KSA wants to join us.
Are there options?
Well, so right now I have it set on as mic also.
I'll repeat any questions that. Just emailed you that link, Dr. Nee, so you can forward it.
Great, thank you.
Emailed you that link, Dr. Nee. Oh, perfect. As much as I like to hear myself speak, that's a joke. Hmm? So fun fact, when I started adjuncting here at Wichita State in 2009, the first class I taught was a programming class, and it was in this very room. Just some fond memories here. Not really.
Bring this a little further away from. You're a loud boy.
Okay, so I think we'll probably go ahead and get started. I think I pretty much know everybody here, but for the sake of the video, since we're recording this and putting it on YouTube, my name is Dominic Canari. I'm a PhD student here at Wichita State University, and for the next 3 days, we're going to be introducing ourselves to the wonderful world of Python as an introduction to the even more wonderful world of computer programming. Also, for those of you who are in the room with me, I also want to introduce Matt, who many of you probably don't know. Matt is an undergraduate RA in Dr. Nee's lab. He's a computer science student going into his 3rd or 4th year of computer science. And he's been learning Python for a while now, and he's been using it pretty extensively over the course of this summer. So he'll be helping out for the next 3 days. Any questions that you have, he'll be able to help just as well as I can. One thing that I do want to mention about this boot camp is that you're not going to be a fully fledged, ready to go Python programmer by the end of it. My hope is that by the end of this 3-day boot camp, you'll have some exposure to some ideas and ideologies, and you'll have all of the tools available to you so that you can start tinkering, experimenting, and trying to write your own programs. You'll still need to look things up. I still look things up every single day. Google is your best friend. But hopefully, when you leave here, you'll at least be familiar with some of the core concepts. And when you look at other programs or when you look at example code online, it won't be completely foreign to you. It'll look familiar, it'll feel familiar, and you can maybe figure out what's going on and how you can use it to your advantage. A little bit about my lecture style. I don't really like to lecture, so if you have a question, feel free to interrupt. If you feel more comfortable raising your hand, I'll try to see you and call on you. But if I don't notice you, literally interrupt me in the middle of a sentence, I won't be offended. I would rather address, most of the time, I would rather address your questions when they come up than for you to try to remember them later when it's out of context. So please feel free to interrupt me as we go. Another thing, I hope you don't expect perfection because I never bring that with me. If you have a question, usually what I'll try to do is I will not only show you the answer, but I will try to also show you how I can come to the answer, what I might search for in Google or in the official documentation to find that answer. Because when you're working on your own and you don't have somebody like me or Matt or somebody else around to just ask a question, you'll have to be able to find the answers on your own. And that sometimes is even more valuable than actually having the knowledge already. So I'll try to demonstrate that, how to find the answers. And sometimes I won't think to, or sometimes I won't think it's important. If you ask a question and I show you something, or if I just show something without showing how I found that, and you want to know, please feel free to ask that because I want you guys to see that part of the process too. So are there any questions before we get started about what we're going to do this week, what we're not going to do this week? All right. So the first thing I want to talk about before we start jumping straight into Python, I want to talk about what computer programming already is. And several of you in this room have already heard this thing from me in some other context, but I want to cover it here for everybody because I think it's really important for people to understand. So out of curiosity, who here thinks they already know what programming is? Hopefully everybody has an idea at least of what programming is, and maybe you have an idea of what coding is, right? So maybe somebody would be willing to share what they think programming, what does programming mean to them? If I said I wrote a program or I do programming, what would that mean to you? Anybody? Yeah, Jake. That is so good. That's an excellent answer. There's only one small change that I might make to it in terms of programming. So for those who can hear, Jake said that a program is a set of instructions for a computer to follow to complete some operation. I think that's pretty close to what you said. And that's a pretty good answer, except that the only change I would make is taking out the word computer, because a program isn't specific to computers. Programming actually exists all around us. Everything that is just a list of instructions is a type of program. Okay, what about coding? What does coding mean? Maybe Daniel has a good one for this.
It's just taking those instructions and turning them into a language that you can understand. Yeah,
so Daniel's answer was taking a set of instructions and converting them to a language the computer can understand. And that's, again, a pretty good answer, but it's not broad enough to encompass all of coding. Coding is really just any kind of translation. We can take the alphabet, for example, and we can speak it A, B, C, D, E, and those spoken words is an encoding of the alphabet. I could also write those letters, the letter A, the letter B, the letter C, and that would be an encoding of the alphabet. I could also put them into Morse code. You'll notice that code is actually part of the name, dots and dashes. That is just another coding of the alphabet. Coding is really just any kind of translation from one representation into another representation. So when we talk about programming, we're talking about solving some problem, some operation, completing some task using a list of instructions. You've seen these in your everyday life. You've seen them as recipes. You've seen them as driving directions. You've maybe seen them as dance steps, and you've seen them as IKEA furniture assembly instructions. When we talk about coding, we're just talking about different ways to represent some kind of concept. The alphabet is a great example because there are numerous encodings that we're already familiar with. When we talk about computer programming, we're talking about those things in the context of a program, some operation, some instructions that the computer can understand in order to complete a task. Coding in the context of computer programming is picking a language that the computer can understand. There are numerous languages available to us, from C and C++ to Java to PHP to JavaScript to Python, to Golang, to Haskell, to Lisp, hundreds and hundreds and hundreds of computer programming languages. The language that I like to teach with is Python. And the reason why is because Python is an easy to read language. If you were learning a foreign language, you wouldn't try to write a letter in Spanish from the start. The first thing that you would probably do is write your letter in English and then word for word, sentence by sentence, translate that English letter into a Spanish letter, right? Often people think that when they're doing computer programming that they just jump straight into the computer code. And that's not a great idea. Even if you are well-versed and fluent in the computer programming language, it's still an uncomfortable language to try to think in. So one of the nice things about Python, there are many nice things. One of the nice things about Python is that it is a relatively straightforward translation from English that we're used to speaking to a language that the computer can understand. It's a comfortable coding for a computer program. Some other reasons why you might like to use Python, besides being easy to learn and easy to read. It is an object-oriented programming language, but it also supports procedural programming and functional programming, which I know probably doesn't mean anything to you right now, but what it means to, in the general sense is that you have a lot of options for how you can structure your program. Sometimes some problems are easier to solve in some ways, and Python lets you choose the way that best suits the problem that you're trying to solve. It doesn't force you to use a specific paradigm. It's also general purpose, which means you can use it for pretty much anything. If you want to make a website, you can do that in Python. If you want to make a chat room, you can do that in Python. If you want to write an experiment that does visuals, you can do that in Python. If you want to process the data from your experiment, you can do that in Python. And it's a very popular programming language. I think recently it was shown that on a very popular website called Stack Overflow, where people who are learning to program can ask questions. Python was as of this year, Python is the most popular language on that website. So arguments against Python. Frequently you'll hear people say that Python is slow, which is technically true, but for 99% of what you're doing, the difference between 0.001 seconds and 0.01 seconds is completely negligible. Besides that, most of the heavy operations, like the heavy mathematical operations that would be really slow in Python, are usually implemented in C and extended into Python. So your code uses that C code without you knowing any C code at all. And so your Python program can be just as fast as a C program. Another reason why you might not choose Python is that it's not completely universal. You can do Python on mobile devices, but it's a real pain. And it's just not very well supported. You can see on the screen there, I have a quote from Pope Francis himself. If you already speak perfect English, there's no need to learn Python. That's a joke about how easy it is to learn Python. And there's a short snippet there that just demonstrates what Python code might look like. As we go through this week of boot camp, whenever we learn a new concept, we'll actually be live coding that, so you can follow along on your computers, or you can just watch my screen. So you'll actually see Python as it is developed. So first things first, I see almost everybody has a laptop, which is good. You should download Python now, because you will probably want it for the rest of this week. And I want to make sure that when you leave at the end of this week that you have everything you need ready to go. So I've allotted some time today for us to do that. So you can go and download Python from the Python website, python.org. There should be a big download button for you there. And by default, it will download Python 3.7.0. That is the current latest version. It just came out a couple weeks ago. You could also use Python 3.6 for everything we're doing. Both of those would be absolutely suitable, but you do not want to use Python 2. Python 2 is old and crusty, and nobody who matters is using it anymore. So just stick with Python 3, specifically 3.7 if you can. If you are, how many people here are Windows people running Windows? Okay, almost everybody. And looks like maybe 1 or 2 people on Macs. So if you have a Mac, you probably already have Python installed on your computer. If you're running, anybody here Linux users? Kind of? Okay, well, if you're running Linux or Mac, you probably already have Python installed. They usually come pre-installed with it. But for Mac, I actually don't know what version it ships with. So if it's not Python 3, then you'll want to download that from the website. When you are running the installer for Python, you want to make sure that there are some advanced options. One of the ones that you'll make sure to check is the one that says adding Python to the path and installing pip. We'll kind of cover what those do later on in the boot camp, but for now, just know that they're pretty important. And for demonstration purposes, I'm going to make sure that I have Python installed on this computer. So python.org, downloads, download Python 3.7. The downloader will ask you if you want to install it for everybody. You can if you'd like. It really doesn't matter. What does matter, though, is checking this box down here, adding Python 3.7 to your path. And the other one that I like to make sure that I have is pip. Make sure you have that. And you want to make sure that you have the Python 2 environment variables, that box there. So those are all checked by default, so you shouldn't have to do anything. So that was it. It's pretty fast. We'll go ahead and click close now. If you want to check and see if you have Python installed, if it's installed correctly, if you're on Windows, you can hit the Windows key and the R button. That'll bring up this little run dialog. That's Windows key and R. You can type the letters CMD in that box and then click OK. That'll bring up a black box that looks like this. And in that black box, you can just type the word Python. And if you see something that looks like this, that means you have it installed correctly. If you don't have it installed correctly, if you went through those steps, Windows key R, CMD, Python, if you don't see something that looks like this, just raise your hand and Matt will come over and help you out. Okay. The next thing that we're going to do is select an editor. The default installation of Python includes idle, which is an editor that you can use for writing Python programs. It is the second to bottom of the line. The bottom of the line is probably Notepad, and then above that is idle. We want to use something that is just a little bit more featureful for our purposes. So there are a handful of lightweight, universal, and open source editors that are available. And what I mean by universal, I mean that you can use them for Python, but you can also use them for other things. If you need to edit CSV files, you can do that with these editors. If you need to edit, HTML file, whatever you have, anything that's plain text, these three editors here that I recommended can handle those. The one that I recommend the most, the current one that I'm actually using for all of my work, is Visual Studio Code. And the name is important. Visual Studio Code is not the same thing as Visual Studio, which you've maybe heard of. Visual Studio is a fully integrated development environment. It is pretty heavy, and there are different versions of it available. There's like a community edition and a professional edition and an enterprise edition. I don't recommend that one. I recommend Visual Studio Code. It's much lighter, and it's actually more steadily developed. They're adding features to it constantly. And for what I do and for what you'll be doing for this boot camp, it will more than suit your needs. So if you don't already have an editor that you like to use, then I would recommend Visual Studio Code. You can download that at code.visualstudio.com. And I will go ahead and do that now. So right on the website, there's a big green download button. On this computer, I don't have administrator rights, so I can't actually install it on this computer. So there's not much that I can show you in the installer, but the installer is pretty straightforward. You can just skip through it. I do have a portable version of Visual Studio Code installed on this computer already, though. So I will fire that up.
gonna take about 1 or 2 minutes to download.
So how many people are downloading Visual Studio Code right now? Okay, everybody is. We'll give it a couple minutes and maybe we'll put on some music for our for anybody who might be watching this YouTube video later. And maybe we don't want to do that, it's copyrighted.
Yeah, quick question. Are there any
Yes.
advantages to Visual Studio over something like Notepad++?
Yeah, the advantage of using something, you mean Visual Studio Code or Visual Studio? Advantages of Visual Studio Code, the primary advantages over something like Notepad++ is that it has an integrated, it has a very extensible platform. So there are hundreds of plugins that already exist for Visual Studio Code. And specifically for Python, Microsoft has adopted and continued development on a Python plugin that is actually the best development environment for Python that I've ever used, including some commercial versions of Python IDEs. So for doing debugging and inspecting code as it's running, what you get out of Visual Studio with the Python extension out of the box is better than what you'll get out of Notepad++. Another reason why I like Visual Studio Code so much is that it is cross-platform. So I can recommend it to people who use Linux, I can recommend it to people who use Mac, and I can recommend it to people who use Windows. I think Notepad++ still is only available on Windows. But if you have, the best editor for anybody is the one that they're most comfortable with. So if you already have and use Notepad++, then you should absolutely use that.
Are there any select additional tabs?
Just let it do the defaults, yeah. Does it require a restart? Don't worry about, yeah, you should check that box. Let it do that, but you don't need to restart just for that. If you can, okay, yeah, don't worry about that. Okay, so it sounds like some of those installations are finishing up. So I'll start to give you just sort of a sort of orient you to Visual Studio Code. The primary screen is the editor screen. We can make a new file, and you can also do that from the file menu. And this is where you can actually edit your code. Yeah. Yeah, I'm not going into details. And yeah, you can, if you can look up at my screen while your install is going, you won't miss anything from that progress bar moving across your screen. So the primary display is the editor. Let's see if I can increase my font size there. It is tab-based, so you can have multiple tabs open. On the left side, there are some buttons. They look really big on mine because I made my font size bigger. The first one is a file browser. So it'll, if you have files open, it'll show you a list of all of those files here, the same as what's across the tabs. And if you open a folder, which is really convenient, it can show you all of the files in that folder. So it's just a really quick way to open other files that you might want to be working on. The second button there is just a search and replace. The third button is for source control. Don't worry about that for now. The fourth button is a debugger, which hopefully we'll be actually using later on in this boot camp. This will basically just let you inspect your code while it's running so that you can actually see what's happening in a program while it executes. And then the last one is the extensions marketplace. I'm not sure why they call it a marketplace, because I don't think you can actually buy any of these. I think you just install them. But you can see by default, at least on mine, it's sorted by popularity. And the #1 plugin extension for Visual Studio Code is the Python extension, which is kind of, I didn't know that, didn't realize that. So Python is very popular with Visual Studio Code. Question? Yeah, you can just close that warning. Git is a version control software. So if you're writing a program and you maybe like want to make a checkpoint, like you've accomplished some important task and you don't want to lose your progress on that, but you need to like do something else and you're afraid that what you might do might break what you've already worked on, you can use Git and other version control systems to make checkpoints in your code along the way. If you have it installed, then Visual Studio Code has a lot of very nice integrated features for managing those checkpoints. But if you don't have it installed, it won't prevent Visual Studio Code from working. Most people that are doing software development would have some type of version control system installed. So by default, it tries to find one. But if you don't have one, don't worry about it. That's sort of outside of the scope of what we're going to cover in this boot camp.
So for the top one in the list, the Python, since we have already got a 3.6.6, we don't have to install it here.
Right. So this extension for Visual Studio Code is not Python. This is just an extension for Visual Studio Code that allows you to do more things with Python as you develop.
So we need to install it in.
Right. Yeah, this isn't going to install Python in Visual Studio Code. This is just going to make Visual Studio Code more knowledgeable about what Python is and does. So if you have, if your installation is finished and you have Visual Studio Code open, go ahead and click on the extensions module on the left-hand side of the window. And then if you don't see Python in the list, you can just search for it. And if you do a search, you'll notice that there are a number of different Python extensions. The one that you'll want is the one that's from Microsoft. There are others, and some of them do other things that add additional features to Visual Studio Code for Python. But for what we're doing this week, this one will suit all of our needs. So you can just click on that install button. It'll download and install the Python extension for you. When it's done, it will give you the option to reload Visual Studio Code. Mine's done there. So I just clicked on the reload button. I probably shouldn't have done that so quickly. But I clicked the reload button and my Visual Studio restarted, and now the Python extension is enabled. There's that Git warning. I'm just going to close it. Git is not installed on this computer, but I don't need it. Another question?
Just for the Git,
if you have, I would definitely recommend having something in place for managing versions of your source code. If you use Dropbox, then that is probably good enough for most of what you're doing. There is a learning curve to using something like Git or Subversion or Mercurial or any of the other version control systems. And for most of what you're doing, the learning curve probably isn't worth it. If you are going to be writing a program for every experiment that you do from now on, if you're going to be doing programming on a regular basis, then it probably is worth the learning curve. But I would expect that for most of you, it's probably not worth the learning curve because you're probably not going to be doing programming every single day. Which actually, that's a great question and kind of a nice segue to another point that I like to make about computer programming. I'm glad that all of you guys are here. It tells me that you have some interest in computer programming, but I know that maybe you're only here because you were told to be here, or maybe you're here because you want the exposure, but you don't actually expect to learn anything. To that, I will just point out that I know how to drive a car, and I do it every day, but I don't consider myself a driver. I have written papers, often poorly, but I've completed them, but I don't consider myself a writer. You don't have to program professionally in order to know how to program. You don't have to be a professional driver to have benefit out of driving a car, right? You don't have to be a professional writer to see benefit in knowing how to write a paper. If you know how to program, there are so many things that will open up to you that just were not previously available. It's kind of like if you didn't have the ability to drive your own car, you'd be limited to public transportation. And I guess Uber now, we have Uber, which is nice, but it's expensive, or at least adds up over time. If you didn't have Uber, you'd only have public transportation. And if you couldn't drive a car, that means you'd either have to walk to places, or you'd have to only go to the places where public transportation takes you. And if you can't program, if you don't know how to write a program, then you can only use software that's already available to you. But if you find an app that almost works, if you're trying to accomplish something for which there is no software, computer programming gives you the ability to drive yourself to that destination. And you don't have to be a professional programmer in order to have that benefit. Okay, so does everybody have Visual Studio Code installed with the Python extension? Excellent. If you don't, we're going to leave you behind forever. Yes, after you install the Python extension, go ahead and hit that reload button. It should just close and open right back up. So now you have everything that you need to start doing Python. For your first introduction to Python, I'm going to introduce you to the Python interactive shell. And we're going to do that from within Visual Studio Code. So I'm going to switch back to Visual Studio Code. And I'm going to close this window so that I can open it again. And from my View menu in Visual Studio Code, I'm going to go down and select the integrated terminal. You can see there's a hotkey for that as well if you're a keyboard shortcut fan. And I'm also going to close my extensions module. Just give me a little more screen real estate. So when I enabled the integrated terminal from the View menu, down at the bottom of my screen, it's split into two. So at the top, I have my editor where I can edit files. And at the bottom, I have this terminal. And in here, we can type commands that the computer understands. The only command that we need it to understand right now is the Python command. So I'll just type Python. And if you do that, you should see a screen that looks like this. It tells you what version of Python you're running. And it gives you a nice little message. You can type help or copyright or credits to view some more information about your installation of Python. And then you should see these three chevrons. Those are indicating to you that Python is ready for your commands. So you can try different things out here. Python can work as a calculator. We can do math in Python. 3 + 3 = 6. Can everybody see my screen okay? By the way, is that font size okay? All right. We can also do multiplication. 3 × 3 is 9. We can do, we can tell it to print messages to the screen. Question? Yeah, if you get lots of red and errors, you should just close your laptop and go home. I'm kidding. Don't leave. Yeah, so let me get back to this. When you typed Python, did you at least see this much? No, okay. So what that probably means is that Python did not get included into your path. That was one of the checkboxes at the beginning. And it should have worked. One thing that we can do is we can force it. So this is going to be different depending on if you installed it for yourself or if you installed it for all users. So I'll try to show both so that regardless of which way you did it, you'll be able to see the way to fix that. So what I'm going to do is I'm going to open the control panel on my computer. I just clicked on the start button and then typed control panel. And on newer versions of Windows, they like to categorize stuff in this fancy way. And I'm not a big Windows person, so I'm kind of used to what I'm already familiar with. So I'm going to click on small icons just so that I can get straight to what I'm looking for. What I'm looking for is this system option. So to show you that again, it started on category. If yours looks like mine, you can change the view from category to icons. And then when it's in the icon view, you'll find an option for system. When you click on that, it'll show you some information about your system. From there, you can click on Advanced System Settings on the left-hand side. And if you're an administrator on your PC, you will be able to type in your credentials there. I can't actually do that on this computer, so I will have to try to find some screenshots, I guess, in order to show you the next step. Okay, maybe this one actually. Okay, so you should have a screen that looks like this when you clicked on Advanced System Properties. Does everybody see this screen for those of you who are having issues? Yeah, that's okay. It's the same. Along the top are tabs. One of those tabs says Advanced. If you click on that, you should see a button that says Environment Variables. And when you click on that environment variables button, you should see a screen that looks something like this. Does everybody see that? For those of you who are having issues with your Python? Okay. So in this list of environment variables, there's one variable that we need to modify. It's the path variable in the system, in the list of system variables. So you'll find path in the list of system variables. If you don't see it there, if you see path in your user variables, that's also fine. Either one, it doesn't actually matter. Pick one of those, click on the path variable, and then click on edit. And when you do, you should see something that looks like this, a variable name and a variable value. So again, you'll find path in your list of system variables, and then you'll click the edit button.
In the top of the window, which one?
To get to there, you have to click on Advanced. And then after you click on Advanced, there's a button that says Environment Variables. And find the one that says Path, click on it, and then click Edit. When you do, you'll see this dialog. There's a variable name and a variable value. The variable value is a list of folders separated by semicolons. We need to add the location of our Python installation to that list of values. So to find the location of your Python installation, there are 3 possibilities depending on which version of Python you installed and how you installed it. The first possibility is in Program Files /Python. That's not where it is on my system, so I can't show you that. The second possibility, the first possibility is in Program Files /Python. The second possibility is in the x86 version of the Program Files folder /Python. And then the third possibility is in your specific user folder. The easiest way to get to that one, and this is probably, if you use the default settings, this is probably where it installed for you. So if you have it found in your program files folders, then it's going to be here. Type an ampersand in the address bar of Windows Explorer. Type an or it's not an ampersand, a percentage symbol. The word app data, APPDATA, and then another percentage symbol. That'll take you to a special folder on your computer that's otherwise hidden. And it'll probably start you in this roaming folder. We're going to go up one directory to app data, and then we're going to drill down into local. Inside of there, we'll go into programs, and this will list all of the programs that you have installed on your computer for just yourself. And in the case of this computer, the only thing that I have installed just for myself is Python. So I'll go ahead and open that. And then there are a couple of Python folders in there. I'm going to open the Python 3732. And then there I see a Python executable that I could double click and it would start for me, which is what we want to get to. But we need our computer to be aware of this. So when you get to the folder that contains the Python executable, where if you double click it, it launches that window we were hoping to see earlier. When you get to that folder, you'll want to copy the path. So I'm just clicking in the address bar. I'm going to copy that whole path to the clipboard. And then in my environment variables, I'm going to add it to the list of paths that my computer is going to search. You want to make sure that you put a semicolon before it, though, because it needs a semicolon between each folder.
If you're using Windows 10, you don't need to do that. You just need to click the add button and then add the full path. And it'll do everything.
Ooh, that's fancy. So yeah, I guess if you're on Windows 10, then this is probably what it looks like instead. So on Windows 10, yeah, you'll want to hit New and add that folder that has your Python installation. Question. Okay, if you're on Mac and it's not running it's not running Python 3, so you'll need to download Python, and you'll need to do another step. So Mac also has a path variable, just like Windows does and just like Linux does. I actually don't know how to modify it system-wide on a Mac, but we can do that. You and I can look at that together later, and then I'll add it to my slides so that that reference will be there. But I think for now, if you're on a Mac and most of what we'll do will actually work with Python 2, so you'll probably be okay there.
Bootology and JP not get the Python path set up. Okay, so you got like more now. Can help with that one.
Yeah, mine was broken, but it's working now. It's broken now. No, it's not broken now. So mine has a user path and the user path was Python. I just copied that and put it into the.
Yeah, it's working. I just had to restart my Visual Studio.
What happened? Restarting, just restart it. Yes. Yes. Okay. How does it work?
Okay. Is anybody else still having problems running Python inside of Visual Studio Code?
I think I got it.
Yeah.
Okay, where goes? Just restarting. Yeah, restarting. Yes.
Okay. So I think everybody is mostly good now. Okay, so if you have Visual Studio Code with Python and everything is installed correctly, which sometimes takes a few extra steps, you'll be able to type Python from the integrated terminal inside of Visual Studio Code, and you'll get a prompt that looks like this. From there, you can type any Python code, and it will be interpreted as soon as you hit the Enter key. So you can see the result right away. This is really useful if you are trying to write some Python code and you're not quite sure like how something's going to work or what the result is going to be, or if it's even like the right command to use. You can come into the interactive Python terminal and just try to type the command. And you can see if it's actually the right thing. So here I get an error. It tells me, oh, that's not a command. That's not defined. So that probably wasn't the thing that I wanted. So we'll be kind of switching back and forth. Obviously, Python isn't only useful in interactive mode. Most of what you'll do is actually writing a Python file and then executing the file as a whole. But the integrated terminal is a nice thing to have so that you can test things out while you're developing. You can see how Python works, how it treats different things if you're ever uncertain. Okay. If you are using a different editor, it probably has a similar integrated terminal. Otherwise, you can use one that's already on your machine. So the first thing that we're going to do is a simple hello world program. So I'm going to actually close my integrated terminal here by typing the word exit and then an open and close parentheses. That'll take me out of Python. And then I can type exit here, or I can just click the X. That'll close the integrated terminal for me. And the next thing that I'm going to do is I'm going to make a new file. And in here, I'm just going to type some very simple Python code to print something out to the screen. Now you notice right now, I haven't saved this file yet. It's just plain white text. But if I go ahead and save this file, let's make a new folder called Python stuff. And inside that folder, I'm going to make a new file called hello.py. Py is the default extension for Python source code. So if I do that, if I save this file with a .py extension, you'll notice that my Visual Studio or your editor will, if you're using a decent one, will color code some of the text. This isn't a necessary feature of Python or of your editor, but it does make it a little bit easier to read code as you're going. You might also get a pop-up like I did here that says that Pylint is not installed. Pylint is another extension for Visual Studio that can check your source code for common mistakes and errors. If you want to, you can install Pylint. I'm not going to worry about it. I'm actually just going to disable linting so that I don't get that pop-up again later. You can install it if you'd like, totally up to you. Eventually, you probably would want it if you start doing a lot of programming. But for this week, we're not going to worry about it. So I've I've typed some Python code. I've saved it in a file. Now, how do I run that Python code? To run it, I'm going to open my integrated terminal again. And I'm going to, you'll notice that it starts me out in this folder, which is not the same folder that I saved that program to. So I'm going to actually do something a little bit different. I'm going to close that thing. I'm going to click on File and then click on Open Folder near the top. And I'm going to tell Visual Studio that everything I'm going to be working on, I'm going to be working on inside of this Python stuff folder. That's that folder that I just created. So I'll go inside that folder and I'll just hit that select button. And when I do, it'll kind of restart. And don't tell me about missing Git again. And there I can see my my hello.py file on the left. I can click on that to open it. There's the code. And if I open my integrated terminal from the view menu, you'll notice that now it opens up. It starts inside of that folder. If I want to see a list of files inside of that folder, I can type the dir command, and it will tell me, hey, there's only one thing in this folder. It's hello.py. If I already knew the name, which hopefully I did since I'm the one that named it, and it's up here on the tab, then I can run that Python file by typing the Python command and then the name of the file, hello.py. When I do that, Python will load that file and execute every line inside that Python file from the top to the bottom. So if I put in another print statement, save my file, and run it again inside the integrated terminal, I'll see both of those lines printed, one after the other, in the same order that they're saved inside of my file. Yeah. Yeah, Python doesn't care about what types of quotes that you use. There is no semantic difference between them as far as Python is concerned. Good question. Other programming languages do not work that way. Other programming languages do make a distinction between double quotes and single quotes. I generally use single quotes because I come from PHP, and PHP doesn't interpolate single quotes, which I don't know, that's probably doesn't mean anything to you, but I use single quotes out of habit. That's a better way to say that. But it doesn't matter in Python. You want to say something? Yeah, that's a good point. If I wanted to use a quote inside of another quote, then I can do that by changing the quotes that I'm using. So if I'm using double quotes for my message, then I can use single quotes inside of it without a problem. If I'm using single quotes for my message, then I can use double quotes without a problem. But if I'm using double quotes, then I can't directly use double quotes inside of that. You can see that the color of this changed. If you really wanted to, though, you can just add a backslash in front of it, and that'll allow you to do it. A little more advanced for today. But is everybody able to create and save a file and then execute that file? That's just typing the Python command and then the name of the file. In my case, hello.py. And then when you hit enter, it will execute your file from the top to the bottom. Just like if you received a set of driving instructions, or when you're cooking and you're following a recipe, you follow that recipe from the top to the bottom. Python does the same thing. It loads your file and runs each instruction from the top to the bottom. Okay. This obviously, if we save this program, this wouldn't get us very far because it doesn't do anything interesting yet. One interesting thing that we can do is grab input from the user. We can use with the input keyword. And we'll explain exactly what's happening here a little bit later on, but for now, I just want you to try it. We can put in a prompt, what is your name? And we can put that in a variable. And then we can use that later. So maybe right here, instead of saying hello world, we'll say hello username. I'll make this a little shorter so it fits. If input's not being color coded, you have Python 3.7. Then I don't know, that's weird, but it'll probably still work. If you are one of the Mac people and you're using an older version of Python, then the syntax for input is one of the things that changed between Python 2 and Python 3, so this might not work for you. But for everybody else, you can try running a program that looks like this. You can see there it's asking me for my name. I can tell it my name, and then it will print my name out to the screen. If you make a mistake, one of my favorite things about Python is that it will tell you, generally, it will tell you exactly where your mistake happened. It tells me, so I ran this Python code, and it gives me a bunch of stuff that I didn't expect. It says name error, the name input is not defined. And if I look a little bit further up, it shows me the exact line of code that's offending it. And one more line up tells me what file and what line number that error occurred. And in fact, if I click on that file and line number, or control click, it'll actually take me to that specific error. Even if I'm in a different file, I'll make another file and I'll be over there. And I can control click on this, and it'll take me exactly to the spot where that error occurred. I can see, oh, I probably didn't mean to do that. Okay, so that is a very rudimentary program, but now you're officially all Python programmers. Round of applause for yourselves. Okay, let's see where we are on our slides. Question?
That bottom part of the jury is different. How did you PowerShell and still says see where you want?
Here?
Yeah, like I don't have the your one is PowerShell.
So does yours look like this? Okay, so to get out of this, so this is the interactive terminal. To exit the interactive terminal, you can just type exit followed by a set of open and close parentheses. The other thing that you can do is you can actually have multiple terminals open. So on this plus button, you can open a second terminal. So here I have two terminals open now, both of them PowerShell terminals. And this one, I can leave my interactive Python session open. And in the other one, I can have my non-interactive Python. And you can even put them side by side if you want to use them simultaneously. So now I have two shells open side by side. In this one, I can run Python interactively. And in this one, I can just run the file.
So what is a shell learning? What is really a shell?
A shell is an interface for you to send messages and commands to some system. The shell that we're all typically used to looks like this. This is technically a shell. It's just Windows Explorer, but this is a shell to your operating system. Also including the start menu is a shell to the Windows operating system. The Python shell, the Python interactive shell, is just an environment where you can send Python commands. That's all that shell really means in this context. Any other questions before we go forward? Okay, so if you still look like Yeah, so if you're probably not in the correct folder. When it looks like this, do you see the folder here that you saved your Python file to? No, okay, so what you should do, the easiest way to do that is to click on the File menu and then select Open Folder. And then browse to the folder that contains your Python code and click on the Select Folder button. Yeah, if it's asking you to save, that you just have a file open still. Yeah, so when you open the folder, you should see a list of files on the left. You can just open it from there, or Control O, or File Open. And then when you open your terminal, the terminal should start in the same folder that you opened. And your Python file should be in there. Another way to run your Python program, if you feel intimidated by the terminal and the shell, another way to run your Python program is just from the debug menu at the top. From the debug menu, you can click on the Start Debugging word. It will ask you what environment you want. We'll just click on Python. And you can see down here a bunch of stuff spits out. It opens a terminal for me, spits out a bunch of stuff, and then starts executing my program. It also opens up the debug panel, which we'll be using a little bit later on when we encounter some problems in some of our code. Okay. So that is the end of our very first slide deck. At this point, you have installed Python, you've installed an editor so that you can create Python scripts, and you have officially executed a program that you have written. Our next presentation, we're just going to jump straight into it, goes into some more fundamental concepts of computer programming. Now, just to give you some context, I have 4 of these slide decks planned for the week. We'll roll with the punches as far as when they come up, but my hope is that we will finish the 4th one early in the day on Friday so that we can spend a couple of hours later on Friday doing more live samples. We'll actually try to write some Python programs to do some typical psychological experiments. There's no guarantees, obviously, if we encounter some different problems, or if you guys have questions, which I hope that you do. We may not get all the way to the end, but I will make all of these available for everybody. And of course, after this workshop, since you're all around here, I am always available and happy to help anybody who's learning or wants to learn. But for now, let's start the next slide deck. So fundamental constructs. In this slide deck, we're going to talk about some concepts of computer programming that apply to any programming language that you might use. We'll cover them in the specific context of Python, the Python syntax for these constructs. But if you learn these fundamental things, they will work in any programming environment. Whether you're writing apps for a mobile device, or you're using Unreal Engine for an experiment, or you're doing something on a web page, the concepts that you'll learn in this slide deck will apply everywhere. So the way that this slide deck is organized is it's organized by constructs. So they're sort of definitional by nature. So the first sort of vocabulary that you should learn when we're talking about computer programming is the concept of a statement. A statement is just a single command, and a program is just a list of commands or a list of statements. We already mentioned how you've already encountered different types of programs in your everyday life, such as recipes, driving directions, dance steps, flow charts, furniture. These are all programs. They're coded in different ways, and they're obviously not programs for computers probably. These are programs for people, but these are programs. And each of these programs contains a list of steps. Each of those steps is a discrete statement. It's one piece of executable code. A single step in the program is a statement. The second construct is the idea of variables. If you've had algebra, then you're probably already familiar with variables. If you haven't had algebra, don't worry, this will be simple. What's important to understand about variables is that computers are very dumb. When you write a program, anything that the computer needs to remember to use later, even if it's the very next step in the program, the very next statement, if the computer needs to remember it for any amount of time, you have to explicitly tell the computer that it needs to remember that thing. It's a very dumb machine. To do that, we use variables. Variables allow us to provide a symbolic name to a piece of data or information, something that's sensible for us to use while we're writing our program. So some examples here. One way to think about variables, if you imagine your computer program as a person and you're giving that person instructions, one way to think about variables is to think about them as sticky notes for that person. If you want that person to remember something, you have to give them a sticky note. And at the top of that sticky note, you might write what the name of that sticky note is. And in the body of that sticky note, you might write the value that's associated with that. So if we write a program that's interested in a person who has a name and an age, we need the computer to remember those things. So we would create a variable called name and a variable called age. And in those variables, we would store the values that are represented by them. One thing to point out here is that within these sticky notes, beside the names, I also have the data type. The data type just defines the nature of the data that that variable is storing. Variables can store text. Variables can store integer numbers. They can store floating point numbers. They can store aggregates of information. So they can store lists of numbers. They can store groups of information. So they can store whole records. But what's important to know is just that each variable will have a data type associated with it. What's nice about Python, though, is that it doesn't force you to know what that data type is ahead of time. You can just use the variable, and Python will figure out what data type you're putting into it. A little bit more nomenclature, though. You'll frequently hear, in the context of computer programming, you'll frequently hear the word string in reference to text. Whenever you hear string in a computer program, just know that they're talking about a piece of text, just a series of letters and numbers and symbols that represents text that you would see on the screen. Float is short for floating point number, which just means a decimal number. Integer means integer. Yeah, and other data types will make more sense than those. So some sample code there for what that might look like inside of Python. If you want to put a value inside of a variable, you use the assignment operator. That's the equal sign. So the left-hand side of the equal sign is the name of the variable, the symbolic name that we want to reference that value by. And the right-hand side of the equal sign is the actual value that we want to be stored inside of that variable. Later on in our program, after we've defined and assigned our variables, we can reference those variables by name, and the contents of those variables will be used in place of those names. So here in this sample, you can see I created a variable called name and another one called age, and then later I'm printing those values to the screen. And if you haven't already, you can type this one up, or you can watch as I type it up on my screen here. You can use the same file. Yeah, that's fine. I'm going to create a variable called name, and in that variable, I'm going to put a string, a piece of text. Whenever you're using a piece of text, a string, you'll want to put it inside of quotes, either the single quotes or the double quotes. And the reason for that is because anything that's not inside of quotes, Python will try to interpret as a Python command. And I can tell you right now that Dominic Canary is not a valid Python command. So Python, if I try to run this program, Python will complain. It will say, I don't know what this is. If I put it in quotes, however, Python will not complain. So now I have a piece of text stored inside a variable. I will put an integer number inside of a variable. And then I will print those values to the screen. I run my Python program. You can see that when it prints, on the line where it prints your name is, it doesn't print the word name. It prints the value that was stored inside of the variable called name. Likewise with age, it doesn't print the word age on the screen. Instead, it prints the value that was stored inside of the variable called age. So those are variables. Very simple concept, but essential to any program that you will be writing. The next construct is an equally important one. You saw these examples earlier, but one of these examples is fundamentally different than the others. Any guesses on which one it is? Yeah, it is the flowchart. The flowchart is fundamentally different from the other examples. Why? Yeah. Yeah, it has options. So there are questions being asked inside this flowchart, and the flow of the program is directed along branches depending on the answers to those questions. The rest of these programs that we've thought about and considered are pretty straightforward. There's no branching, there are no questions. You execute one step after the other, and you never have to think about what you're going to do next because you just pick the next thing in the list. A flowchart is a good proxy for a computer program because it allows us to do branching. These are also known as conditional statements or if-thens or branches. Throughout the week, you may hear me refer to them by any of those names, but just understand that they're all referring to the same thing. It's just the idea that you can ask a question in a program and then perform a different set of instructions depending on the answer to that question. You can follow a different branch of execution. So a good example of this that I like to talk about or like to think about is an autopilot, a self-driving car, if you will. If we were to write a program for a self-driving car, we might model that program as a flowchart. And one question that our autopilot program might ask is whether or not there is some obstacle ahead of the vehicle. And if there is an obstacle ahead of the vehicle, we will tell the vehicle to stop what it's doing. But if there's not an obstacle ahead of the vehicle, then we will allow the vehicle to drive forward. Congratulations, you just did artificial intelligence. That question is our conditional statement. The code below it on the yes branch will only execute if this conditional statement is true. The code on the other side of the branch, the no branch, will only execute if the answer to that question is false. All of the questions that we will ask in our computer programs that we'll be doing this week will be yes/no questions. So you can always think of them as either being true or false statements. They will either execute a set of instructions or they will not execute a set of instructions. To demonstrate that, we will write a short program maybe after we print our user's age, we'll want to print a special message depending on what their age is. So the first thing that we'll do is we will ask our question, whether age is greater than, let's say, 70. This statement, we'll try this statement inside the Python interactive terminal first. So yeah, you remember that I can type in numbers into the Python interactive terminal, but I can also type in operators here. So just like I could type 12 plus 45, I can also use comparison operators. So I can ask a question, is 12 greater than 45? Of course, it's not. Python tells me that no, 12 is not greater than 45. The statement is 12 greater than 45. That statement is false. I can also ask if it's less than 45, and Python will tell me, hey, that's true. If we want to know if two things are equal to each other, we can use the not equals operator, which is just an exclamation point followed by an equal sign. Python tells me it is true that 12 is not equal to 45. And if we want to know if something is equal to something else, any guesses on what that operator is? Anybody who's less experienced in programming? So you might guess that the comparison operator for equality would be an equal sign. But if you try to do that, Python will tell you that that's an error. It says it can't assign to a literal. The reason why it's telling you that's an error is because the equal sign we've already seen. The equal sign is the assignment operator. We use the equal sign when we want to put a value inside of a variable. Down here, Python is telling me you can't put 45 inside of 12 because 12 isn't a variable. We can't assign the value of 45 to the number 12. And actually, if you're running Python 2, you can. But Python 3, you can't do that because things go crazy.
And just to give you a quick comment, that was the number one thing I experienced when I learned programming in middle school, high school. And yeah, in high school, and that really killed me. It took me forever to understand how I can make a number, 12 and then 45. That's the thing.
Yeah, actually, a nice thing to point out, another nice thing about Python is that if you try to do something like this in Python, it will tell you that that's an error. In other programming languages, when you use an equal sign, when you mean to use a comparison operator, it will let you do that. And your code will execute, and you will never know that you made that error. And it will change the value of a variable when you didn't mean for it to. So Python, another nice thing about Python is that when you make that mistake, which is a very common mistake, it'll tell you, it'll give you a heads up. So to do an equality comparison, you'll actually want to use two equal signs. 12 is equal to 45, false. 45 is equal to 45, true. So this is how we can ask questions about numbers in Python. If we want to put that inside of a conditional statement, if we want to execute a list of instructions, but only if the answer to this question is true, then we'll put it inside of an if statement. And we will literally write the word if. We'll ask the question, if age is greater than 70, then, I used a colon there, perform some instructions. Now, one thing that you'll notice if you're using Visual Studio Code, that when you type a colon at the end of a line and then hit enter, it will indent your next line. This is important because in Python, everything that's indented under a statement such as a conditional is considered part of that branch of execution. So the way that this code is formatted right now, when I execute it, both of those print statements will happen when their age is greater than 70. If I unindent, This line of code will be executed regardless of the answer to this question. So Python will ask, is age greater than 70? And then if it's true, it'll execute both of these lines of code, and then it will execute this line of code. If this statement is false, it will skip these next two lines of code and jump straight to the next one. Let's try it out. I had 33 in there, and it says it didn't say anything about 33 being old, so it just skipped right over that. And I forgot to save my file. The easy way for me to know that I didn't save my file is that up at the top of my tab, there's a little circle there where the X normally is. If I hit Control S, you see that circle goes away, indicating to me that now my file is saved. So if I execute it again, it'll print that third statement that I was expecting to see last time. Make sure you save your programs. If I go back up and change age to some higher number, like 80, something that is larger than 70, and we run our program again, you'll see that it prints those statements that were only printed when age is greater than 70. And it prints them both. So this is a very basic conditional statement, also known as an if-then statement. Besides if-then statements, we can actually stack questions. So if the age is greater than 70, maybe we want to print stuff about them being old. But if their age is anything else, 70 or below, we can tell Python to execute some other commands. Question there. Okay, so if you're getting an error that says unexpected indent, then probably what's happening is you have, I'll demonstrate that here. I get the same error on mine, and the reason is that I have this print statement is indented 4 spaces over, but it's not part of an if statement. So if I get rid of the white space before this, that'll fix that problem. Another reason why you might encounter that is that Python treats tabs and spaces separately. The default, the convention in Python is to use spaces, specifically 4 of them, to indent your lines of code. And you can see in my program, those are actually spaces, not tab. The official convention in Python for all Python standard code will be to use spaces. Whether you use spaces or tabs is totally up to you. And to be completely honest, I use tabs in my programs. So I don't follow that Python convention. And there are a couple of other Python conventions that I don't follow. The most important thing about those conventions is that you are consistent within your own code. In fact, if you're not consistent, I'll show you what happens. I'm going to find every instance of 4 spaces and replace it with a tab character. Whoops. I'm going to find every instance of 4 spaces and replace it with a tab character. Now you can see there's just 1 character there, not 4. It's just a single tab. And if I execute this program, Python will happily run it. But if I change this one back to 4 spaces, so now I have 4 spaces here and just a single tab here, Python will complain. It tells me unindent does not match any outer indentation level. All that really means is that my indentations don't match. Here I have a single indentation of a 1 tab character, and here I have a single indentation of 4 space characters. Python says, I don't understand what you're trying to do here. So it doesn't matter what you use as long as you're consistent. Officially, Python recommends spaces. I like to use tabs. What you use is up to you. Question?
So what about the isn't another if then statement? You use a different like use 4 spaces?
Yeah, you could. So even down here, so in this top one, I have 4 spaces rather.
Yep.
In this bottom one, I have a single tab. Yep. And Python will run that no problem. Okay. You should never do that though. If you're going to use tabs everywhere. If you're going to use spaces use spaces everywhere. If you're not sure what to use, then just use a good editor like Visual Studio Code and let it decide for you. I didn't have to think about what I was using here because Visual Studio Code automatically indented this line for me. Okay, so far you've seen with an if-then statement how we can ask a question, perform a set of instructions if the answer to that question is true, and then perform a separate set of instructions if the answer to that question was false. But we can further stack conditional statements. So maybe we don't just care if they're old or not old. Maybe we care if they're maybe kind of middle-aged. So we can first ask the question, are they older than 70? Then we can say if they're not older than 70, but they are older than 35, then print some other message. Right, exactly. The conditional statements, the first one will execute, and if this one is true, it'll perform the instructions that are indented underneath it and ignore the rest of the conditional statements. If it is false, then it will ask the question about the very next one in line. So if you get these, changing the order of these questions will change the flow of the program. So yeah, it'll ask if they're 70. If they are, it'll print these messages. If they're not older than 70, then it'll ask if they're older than 35. If they are, it'll print this message. And then if they're not older than 70 and not older than 35, then it will print this message. And then of course, lastly, because this line is not indented, it'll print this message no matter what. So we can test that out. We'll run it right now. Age is set to 80. It says I have a syntax error. Oh, I forgot to put my variable in there. If age is greater than 35, it says you are old, you're so old, dinosaurs and stuff. If I change that number to something less than 70 but greater than 35, 55, and run it again, it tells me you are middle-aged-ish. And if I pick some number that is not greater than 70 and not greater than 35, let's say 35, because it is not greater than 35, then we should see you are not old at all. Any questions about conditionals so far? Good. Yeah.
What's the difference between if, else if? Well, I guess else if and just that else is different.
Yeah, so you always have to start with an if statement. If you want to ask another question, if that first statement is false, you want to ask a second question, then you would use an else if or an ELIF. And then if nothing above this was true and you don't want to ask another question, you don't care about anything else, then you would use an else. The if always has to be the first one, and the else, if you have one, always has to be the last one.
That's it. Everything else above it.
Right.
False, right?
If you had a bunch of else ifs that did different things,
Yeah, different.
yeah. This else would only execute if all of these were false. And in fact, it goes up the chain like that. This one will only execute if all of these are false. And this one will only execute if all of these are false. And this one will only execute if all of these are false. And this one will only execute if all of these are false.
So it stops.
As soon as it finds one that's true, it executes the statements that are inside of that question and then stops checking the rest of the questions. Yeah.
Just a quick comment. In the first condition, actually you can add one more condition within the first condition.
Yeah.
One extra layer so that you can anything age when the age is greater than 100,
Yeah, so there are a couple of fun things that you can do with conditional statements. The first thing that one of the first things you can do, I guess, is you can ask 2 questions at the same time. So maybe we care if their age is 70, but maybe there are some people that are sensitive about being called old, and maybe their names are me. And we can check 2 values at the same time. So we can ask if they're older than 70 and their name is not me. Then we can print, you are old, you're so old, dinosaurs and stuff. What this means is that if name is equal to ni, then this statement considered as a whole will be false. Because this first part, age is greater than 70, if we make it true, age is greater than 70, that's true. But name is equal to ni, which means that this statement will be false. And the result of a statement which is true and false is going to be false. True by itself is, of course, true. False by itself is, of course, false. But the combination, the and of true and false, will always be false. So here, this means that we're only going to print these messages for people that are older than 70 and not named ni. Another thing that you can do, so besides and, there's also or. So this would mean that if they're older than 70 or they're anybody besides ni, then print those messages, which in this context doesn't really make sense, but maybe there's somebody that we really don't like very much. And so we want to always make fun of them no matter what. So we can say if they're older than 70 or it's Matt, because Matt, then these messages will always print for that person or for anybody who's over 70. So there's ands and ors. The other thing that you can do is that remember that a program is just a list of instructions. When you create branches, those branches are just other lists of instructions. And so we can actually, inside of our sublist of instructions, include anything that's a valid instruction, such as another conditional statement. Only if you're older than 70, though.
Yeah.
So here, the first thing that Python will do is that for this conditional statement, it will check to see if their age is greater than 70. And if that's true, none of the rest of these are going to execute. But everything that's indented from below that if statement will be. So the first thing it does there is it checks to see, hey, is this person ni? If it is ni, then print you are wise. And if it's anybody else, if it's any name besides ni, then print you are old. And of course, you could continue to go further and further down the line with those nested if statements, or what they're called. Okay, any other questions about conditionals, branching, if-then statements? Okay, the next thing is, the next construct that I want to talk about is functions. And one of my favorite ways to talk about functions and ways that make people appreciate them is in the context of recipes. So does anybody here cook sometimes? Has ever followed a recipe? Has ever cracked open a recipe book? Okay, good. Do you consider yourself a cook? Couple of you? So, by the way, just because you write a couple of programs, you don't have to consider yourself a programmer, right? Just like if you cook a few times, doesn't mean you have to consider yourself a cook. Even if you cook every day, I cook just about every single day, but I don't consider myself a cook. I program every day. That doesn't mean that I have to consider myself a programmer. Anyway, in the context of a recipe book, by the way, this is the best recipe book that I'm in love with this book. If you're looking for a new recipe book, highly recommend America's Test Kitchen. Yeah, it is phenomenal. Anyway, let's say that you are writing a cookbook because you are a cook and also a writer. Kudos to you. And you're writing a cookbook. And let's say in that cookbook, you have 15 different pasta dishes. And all of those 15 pasta dishes use one of two possible sauces, either a red sauce or a cream sauce. If you were writing those recipes and you had half of those 15 pasta recipes, I guess a little more than half, we'll say eight of those pasta recipes all use the same red sauce recipe, would you copy and paste that red sauce recipe into each of the pasta recipes? Probably not. You could. It would make your cookbook a lot bigger if you did that with all of your recipes that used sauces. But another thing that you could do instead of doing that is you could just put the red sauce recipe in one place and then refer to that recipe in the pasta recipes. So when somebody wants to make spaghetti, you don't have to have all of the instructions for making marinara. You can just tell them, hey, inside of the spaghetti recipe, you can put a single line that says, go to page 22 and make the red sauce listed there. And then when you're having them make lasagna, you can put the exact same thing. Hey, go to page 22 and follow the red sauce recipe there. The benefit to you as an author is you don't have to copy and paste that same code 15 different times. Additionally, if you find out that there's some problem with your red sauce recipe and you want to add a teaspoon of sugar to it, you don't have to change it in 15 different places. You can just change it in the one place. And for your readers, maybe they already know how to make red sauce. Maybe they're well-versed in red sauce. Maybe they don't even like your red sauce recipe. They have their grandma's red sauce recipe that they want to use. They don't have to ignore an entire block of instructions inside of your lasagna recipe. They only have to ignore a single line of code. Or maybe you have multiple red sauce recipes and you want to be able to swap them out easily. It's much easier to do that if you reference the red sauce recipes instead of copying and pasting those red sauce recipes into every other recipe. That's what functions are in a computer program. They're lists of instructions, just like any other part of a program, but they have a name that can be referenced by other lists of instructions. As we talk about these throughout the week and in other contexts, you may hear these referred to, besides functions, you may also hear them referred to as subroutines or methods or some other names. Just know they're all talking about the same things. They're just smaller lists of instructions that have a specific name, like red sauce. So I want to do a quick demonstration, and I'm going to go to my slide notes real quick. I don't have them on that one. Okay, so to write a function in Python, I'm going to delete actually, I'm not going to delete everything yet. I'm going to, at the beginning of my program, I'm going to define my function up there. And the reason why I'm doing it at the beginning of my program is because you may recall that when we give Python a file, it executes the file from the top to the bottom. If I want to reference a function and other pieces of code, Python has to already know about that function before I can reference it. So if I put it at the top of my file, then it will be the first thing it knows about. So the first thing when you're defining a function is the keyword def, D-E-F, followed by the name of the function. If this were your pasta sauce recipe, this would be marinara or white sauce or whatever. For this program, maybe I want to maybe I want to write a function that asks the user for some input. So I'm going to call this function prompt. And yeah, so I'm gonna write define, and then I'm gonna give it a name. I'm gonna call it prompt. And then I'm gonna do an open and close parentheses. And we'll talk about what those mean here in a little bit. But for now, just type an open and close parentheses followed by a colon. Again, here, if you press enter, you'll see that your editor probably automatically indents you 4 spaces over, which just means that anything that's indented below this definition line, at least 4 spaces over, are going to be the instructions associated with this function definition. So I'm going to input something. I'm going to print something out to the screen. And then I'm going to get a value from the user. And then I'm going to return that value. Now, what's important to understand about functions is that what makes them a little bit different from something like a marinara recipe is that functions can be used more so like in the mathematical sense, where we can provide some input, some parameters to a function to tell it how to execute. For example, maybe I want to print a message to the screen, but I don't always want it to be the same message. Maybe I want that message to be different each time. So inside of the parentheses in my function definition, I can create the name of a variable there, a parameter to this function. So here I've defined a variable called question, and I can use that variable just like any other variable. And what that means is whenever I'm using this function later, in order to use it, I have to specify the value for this variable. So I'll go ahead and delete all of that. So now if I want to prompt something, on the screen, I will call my function. You'll notice that I'm no longer indented because this instruction is part of my main program. It's not part of this function definition. It's part of my main recipe. I'm going to call that function by typing the name of the function, followed by an open and close parentheses. And inside of those parentheses, I'm going to type the value that I want this variable to take on. We'll do, are you ready? So we're not done yet, but we're going to run our code as it is anyway. It's helpful, especially when you're first learning how to program, to execute your code periodically, even if it's not complete yet, so that if there are errors, it's easier to identify them when you've only made a few small changes. Sort of like a controlled variable, I guess. So here, actually, before I even do that, I don't even want to execute this line of code yet. I just want to see if everything I have here is correct, if there are any errors in what I've typed so far. So because I don't want to execute this line yet, and I also don't want to delete it because I do want it later, I'm going to add a comment marker. Comment marker is the hashtag, aka pound symbol, aka octothorpe. Anytime that a line contains a comment marker, anything to the right of that marker will be completely ignored by the Python interpreter. You'll notice that my editor makes it green, which just visually to me indicates that that's not actual code, that's just a comment. Exactly. Usually you'll see comments like this marked inside of the code as reminders to the people looking at the code, the humans looking at the code, as to what the code is actually doing at this point. So for example, here I've commented this line out. If I wanted to leave a comment for myself, I might just write, commenting this out for testing purposes. And you can also put comments at the end of lines. So I can explain what a single line is coding by doing something like this. So let's run this program so far. The only thing that I've done is define a function. I never told Python to actually use that function. So when I run this, Python doesn't do anything. But if I had made an error in here, maybe I forgot that parentheses, Python would give me the heads up on that. It says, hey, your syntax is invalid. I first noticed it on this line of code. So far, when I don't have any typos, there are at least no errors that Python can see. When I take that comment out, now I'm actually telling Python, hey, do you remember that marinara recipe I told you about earlier? Well, now I want you to make that marinara sauce. Now I want you to perform the commands that are included inside of the function called prompt. So if I run this program again, you can see that it did exactly what I told it to inside of that function. It prints a message to the screen and then grabs some value. It's waiting for me to type something in. Now, maybe I want to do a little bit of defensive programming, which is not unlike defensive driving. Defensive programming means that you don't trust your user very much. And so you want to try to account for all of the things that your user might do. So maybe if we're going to get some value from the user, and we're going to say if we're going to change this value to answer. We're going to say if their answer was yes, then return true. Or if their answer was capital yes, then return true also. Or their answer was a lowercase y, or their answer was a capital Y. If they respond in any of these 4 ways, then we're going to return true. And if they return if they type anything else besides those 4 possible answers, then we'll return false. And now we have actually kind of a useful function, because this function is going to either return true or false, we can use this function inside of a conditional statement. So if they are ready, we can do something. And if they are not ready, then we can do something else. So if we run this program and we type a little y, it runs program start. If we do a capital yes, it does program start. And if we type anything else, it'll perform the instructions inside of the else statement. If we, one of my slides is out of order. If we fix our slide deck, actually this slide is the one that's out of order. Okay, sorry about that. So just to give you a little bit more context, like so far you've seen a very simple function that has a few lines of code that seemingly has some value. But to really drive the point home, imagine we're writing our autopilot program again for a car that looks something like this. And you might recall before that we had a conditional statement that asked, is there an obstacle ahead? And if there is, we want it to stop. But if there's not, we want the car to drive forward. But maybe we have some type of differentially driven wheels on our car, and we need to turn each motor on. And because these motors are oriented in opposite directions, we need to spin one motor clockwise and the other motor counterclockwise in order for the car to go forward. And so if we were writing our flow chart for our program, it might look something like this, where if there's no obstacle ahead, we'll turn the left motor, we'll give it a positive bias, and the right motor will give a negative bias. So they spin in opposite directions. When you immediately look at this flow chart, can you tell by looking at this part of the flow chart that the car is going to go forward? Probably not. You'd have to have some pretty intimate awareness about the car and these motors in order to understand that L motor positive and R motor negative means that the car is going to move forward. So a better way to do something like that would be with a function. you can put those commands, those instructions for turning on the motors inside of a function that you would name drive forward. So that in your main program, instead of referencing those motors directly, you can just say drive forward. It makes more sense from a flowchart perspective, but it's especially easier for you to read, because now I can look at this and I can know, oh, if there's not an obstacle ahead, the car is going to go forward. So expanding on that flowchart idea, this is what your flowchart might look with functions defined. You have a drive forward function that says to turn the motors, the left motor positive, the right motor negative. And you could also define a drive backward function that makes the left motor negative and the right motor positive. These have good symbolic names that are easy for us to read in English, so that whenever they're referenced in the main program, it's easier for us to understand what they're doing. And just in case these two little things don't drive the point home enough, imagine that we also had to turn off the brakes independently in order to drive forward. We'd have to add 2 more commands to that. But then imagine that in order to turn off the brakes, we first had to check to see if the brakes were on, because trying to turn off the brakes when they were already off might cause an error. So then we'd have to add a conditional inside of this statement to check the status of the brakes first and then turn them off if they are on. If we have all of those things inside of this function, imagine what this flowchart would look like without the function defined. All of those would have to be defined inside of this flowchart, and it would be impossible for us to glance at and understand what's happening there. Functions are your friends. Any questions about functions? I will also point out, this is the fundamental, the basic definition of a function. A function will have a name. It may or may not have a list of parameters, values that are necessary for the function to execute. If it doesn't have them, then they wouldn't be presented there. If it does have them, they will be. You can also have multiple, so you can have other values here as well. If you wanted to ask 2 questions, for example, you would just define them both. And then optionally, each function can return a value. This function prompt will return either true or false, but a function may not need to return a value. A function may just need to perform some instructions, and then that's it. In that case, you just wouldn't have a return value there. The other thing is that because this function is returning values, if we want the computer to remember those values, we can just use a variable for that. So I'm going to take my prompt instruction here. I'm going to cut it out. I'm going to put it into a variable called ready. I'm going to call it is player ready. I will use the equals operator for assignment, and I will put my function call next to that. I'm going to call this function and then take whatever this function returns and assign it to this variable, so that now I can use that variable later. Okay. Next construct is loops. A loop is exactly what it sounds like. A loop allows you to perform a set of instructions multiple times. In the context of our autopilot car, a loop would look something like this. After we find out if there is an obstacle ahead, if there's no obstacle ahead, we'll tell our car to drive forward with our handy function. And then we'll add this branch that tells it to ask the same question again. So that as long as there is no obstacle ahead, this instruction, drive forward, will continue to be executed. Visually, you can see that this creates a loop, a square loop, but it's still a loop. And that's where loops get their name. It's literally from this loop structure. So to demonstrate a loop, one thing that we might do is we might write a very simple guess the number game. So to start, we're going to come up with some random number. And for now, I'm just going to type it in. 48 is the magical number. person running our program doesn't know that, but we know that. And then we're going to ask the user for a number. We'll say enter guess. We will store their guess inside a variable. And then we will determine whether or not their guess is correct. If guess is equal to the number, then print the message to the screen. Otherwise, print a different message to the screen. Now, if we run this program, we'll see that we have to be a very good guesser because we only have one guess. As soon as we enter that one guess, the program exits. Oh. So yeah, so this is a fun error. So earlier we talked about different data types. You'll notice that the number that I told Python to check against is the number 48. When I entered the number 48, though, Python said, you lose, which is not what I expected because I typed 48 and it should be checking against the number 48. So to troubleshoot this, we're going to introduce ourselves to the debugger, which is kind of an advanced concept, but that's okay. This is just an exposure. So if you don't follow, if you're not doing this with your own, just follow along on the screen here. I'm going to add a breakpoint to my code so that Python will execute only up to that spot, and then it will stop so that I can see what the heck is going on with my program. And my program was running fine up until this point. This point is where there seems to be some kind of problem. So I'm going to add a breakpoint by hovering over the margin, and where you see that red circle, I'm just going to click there, and it turns that red circle on. So now Python will execute all of the code up to there and stop before executing that code. And then from the debug menu, I'm just going to hit Start Debugging and tell it I'm running in a Python environment. It opens the terminal for me, and down below, it's on this line of code, input guess. So it's waiting for me to enter a guess, and I will enter 48, which is what the number should be, and I will hit enter, and then it stops. And you can see that it highlighted this line of code, and it put a yellow marker in the left-hand margin, and it's telling me that it is currently stopped before executing this line of code. And then on my left-hand side here, I'm going to open the debug panel. And when I do, I get a bunch of other panels inside, and I'm just going to kind of spread these out because the panel that I'm interested in, actually I'm going to collapse them. The panel that I'm interested in is this local panel for variables. What's handy about this is it will tell me the value of every variable inside of my program at this time. Right now, there's a variable called number, and it has a value 48. There's also a variable called guess, and it has a value of 48. But hopefully you can see the difference between this 48 and this 48. One of them is a number, an integer value. The other one is text. So I've asked the question, is the text 48 equal to the number 48? And because their types are different, Python says no. The number 48 is not the same thing as the text 48. So if I want to do this comparison, I need to convert either my number to a string or my string to a number. Question?
On the left panel, local var, can I find the local variables?
So you need to click on this symbol here first.
Yeah.
And then you should see, so there you'll probably, oh yeah, so if from the debug menu, if you haven't started debugging, debug menu and then start debugging.
Oh, okay.
And then your program will run up to your breakpoint. So if your breakpoint is below your prompt, then you will need to answer the prompt before it will continue. So in order to convert, we can go either way. We could either convert the number to a string or the string to a number. It doesn't actually matter which one we do, but to do that is the same procedure either way. To convert a number to a string, you can use the str function to do so. And to convert a string to a number, you can use the int function for integers to do that. So you can do that anywhere. We could do it here inside of our conditional statement. We could do it here right when we get the input, or we can do it afterwards. We can change the value of guess to be equal to the integer conversion of what they typed in for their guess. So here I've made some changes to my program. I'm going to restart my debugger. So we'll go through all of the same steps again. I'm going to move my breakpoint back to where it should be, though. I'll restart my debugger. And again, it's asking me for my guess. I'll type in 48 one more time. And now when I look at my variables in my watch window, I can see that number is the number 48, and guess is also the number 48. So if I'm happy with what I have there and I want to go ahead and go to the next line of code, then I can use this step button to step into the next piece of code that Python will execute. So right now it's stopped on this line. If I click this button, it will perform this line and then stop on the next one. So I click that button and it stops on this one, telling me that this is the next line of code that it's going to print, which is the one that I expected. So if I'm like, okay, good, just finish the rest of the program, I can just hit this button here and it will continue executing the program like normal. So there we go. We can see I entered 48 and it says you win. So that's the Python debugger. And you have access to that because you installed the Python extension. And it is a very handy feature when you are running some complicated piece of code that the error is not apparent until you're running it in some specific context. You can use the debugger to stop the program, to sort of freeze it in place and look at everything that's happening. Okay, so we're not talking about debugging right now. We're talking about loops. And right now I have a pretty terrible program that only gives me one guess at what this number might be. I can keep running the program, but that's not very much fun. I want this program to keep asking me 4 guesses until I guess the number correctly. So Python has a couple of different loop styles available to it. One of them is a while loop. A while loop is like an if statement, except it will continue to execute the instructions repeatedly until the question is no longer true. So here, I'm going to change this if to a while. Now this says while the guess is the number. I want to say while the guess is not the number. While the guess is not the number, I'm going to print guess again. And then, so this asks the question, is the guess that they entered not equal to the number? And if it's not equal to the number, it'll perform whatever instructions are indented below it. And every time it gets to the end of that list of instructions, it'll ask the question again, and then again and again and again. So for what I wanted to do is I wanted to print this statement, guess again, and then I want it to guess again. So I'm going to, for now, I'm going to copy and paste my guess code from before and paste it below my guess again print statement. And then I'm going to take my you win statement and I'm going to unindent it. This way, when my program executes from top to bottom, first it will ask the user for a guess, convert that text guess to an integer guess, and then ask the question, is the guess incorrect? And if it is incorrect, it will print guess again, ask for another guess, do the conversion, and then when it gets to the bottom, this is the end of the instructions for this loop. It'll go back to the top and ask this question again. So hopefully, if I run this program, we can guess as many times as we want until eventually we get to the answer we should. Now, one thing that you might notice is that we copied some code and we pasted it. And this is just like that marinara recipe. We don't want to have to do this because maybe we want to change the program later so that instead of printing out to the terminal like this, maybe we wanted to do a pop-up, or maybe we want to change the text of enter guess. Maybe we wanted to say something different. We don't want to have to change it twice. We want to only change it once. So this is a perfect example of when we might want to create a function. So you can see here I'm typing a very descriptive name for my function so that when that function is referenced later, I'll know exactly what that function is doing. I'm going to take my code and indent it under that function and make sure that it returns the converted value. So that now, instead of reusing these 2 lines of code each time, I can just use this function, which is a proxy for these 2 lines of code. And I can do that in both places. So now my code is shorter and hopefully easier to read. And I have, it tells me get user guess as number is not defined. And I can see that I didn't name these the same. I have get users guess up here and get user guess down here. So there we go. Now we have a very simple program that includes both a function and a loop. If we would also like to incorporate a conditional statement, technically we already have one in our loop, but we can also use an if statement. We can say if the guess is less than the number, then we can say that they're too low. And otherwise, we can say that they are too high. Now we have a program that includes a function, includes a loop, and includes some conditional statements, and also variables. This program includes everything that we've learned so far. Any questions about that? You're doing good? Okay, and that's out of place. We're gonna talk about, oh, actually, yeah, so these are just some final notes about functions. And this is actually my last slide today, which is kind of crazy that we're finishing pretty close to on time. When you define a function, I'm gonna start a new file here. When you define a function, you can create variables for that function. And you can do whatever you want with them. So if I write a program that looks like this, just defines a function, and inside that function, I create some variable and assign that variable some value. And maybe even print that variable to the screen to prove to myself that that variable exists and it contains a value. I can run that function by referencing it. Now let's see what happens. Probably exactly what you would expect. It prints DOM to the screen. Now what's maybe not what you would expect is if I try to print that variable down here, Python will give me an error. It says my variable is not defined. This may be unexpected because my variable is defined, but it's defined specifically within this function. When you define a function, you define a scope for that function. Scope here, it sort of just means the world in which those variables live. This my variable function is only available inside of this function because that is where it is defined. Because it's not defined outside of, it'd be kind of like in your marinara recipe. If your marinara recipe called for tomatoes and your pasta recipe said, take those 12 tomatoes. Well, if you're looking at your pasta recipe and your marinara recipe is on a different page of the book, you wouldn't know in your pasta recipe to do anything with the tomatoes, right? The same thing is happening here. These are the tomatoes that are part of my marinara recipe. But in my pasta recipe, I don't know anything about tomatoes because that's on a completely different page. The same thing happens the other way around. I could take this variable and put it down here. Now my variable exists inside of my main recipe, and I can print that out to the screen to prove to myself that it's there. It's definitely there. But now if I call my function afterwards, Python still prints its value. What if I change the value of that variable? I'm talking about pasta. I'm going to print my variable, then call my function, which should change my variable, and then print it again. And I want you to take just like 10 seconds to try to consider what we expect the output of this program to be. First, we have my variable equals DOM. And so if we print that to the screen, we probably know that it's going to print the word DOM. And then when we call my function, it reassigns my variable to pasta and then prints it out to the screen. And maybe we'll make this, we'll also print out inside here so that we know that this is inside of the function. And on these, we'll print outside so that we'll know that those print statements are coming from outside of the function. So first it'll say DOM, and DOM will be printed outside. And then the variable, my variable, gets reassigned the value pasta. And then that gets printed with the word inside. So we probably would expect to see inside and then the word pasta. But then what do you think will happen here? We print outside and then the value of my variable again. Let's find out. What happens here is that this my variable and this my variable are not the same variable. The value of this my variable gets reassigned to pasta, but that does not change the value of this my variable. We can see that the final outside print statement still prints DOM, even though we called my function, and my function should have reassigned the value of my variable. The same thing is true for parameters. So when you define parameters for a function, like earlier we had something like, I don't remember what we called it, but I'm going to call it message for now. This is a variable, and this variable only lives inside of the scope of this function. If we want a variable inside of a function to actually reference a variable that lives outside of the function, we can do that using the global keyword. The global keyword at the top of a function definition tells that function that we're going to use a variable called myVariable, and that function lives outside, or that variable lives outside of this function. So let's execute this. And we can see that when we reassign pasta to my variable, the last print statement prints pasta instead of DOM, because we told this function to use the global my variable instead of the local my variable. You know, something similar happens when we use parameters. we'll just do this, print message. So down here, we're going to define a variable called message. We'll print that to the screen. And we'll call the function, and we'll send it some other message, which is going to print that to the screen. And then we'll print our outside message again. And we'll see something similar to what we saw before. The outside message and the inside message are different. Other message versus my message. Even though this name and this name are the same, they are different variables. This is called scoping. This variable scope is this function. This variable, even though it has the same name, this version of message only exists in this function's context. It's one of those gotchas that might bite you later. And yeah, and that is everything that I wanted to cover today. So we have about 13 minutes left for any questions that you guys might have or any demonstrations that you might want to see. I know we haven't seen very much of Python yet, so there's not a lot that we can demonstrate using only what we've seen so far. But is there anything that you would like to see or any questions that you might have? Okay, well, if not, then we will end today's session on that note. And then tomorrow we will pick up with more intermediate topics in Python, which include some advanced data structures, exception handling, organization of Python programs, and how to interact with files. So reading files into your Python program and processing them, and also creating output files like you might if you were performing an experiment. So yeah, so if you're joining tomorrow, be prepared to talk about those things, and I will see you guys then.